Imagine waking up to a world where interstellar travel isn't just the dream of science fiction, but a reality within humanity's grasp. A universe where light years of distance no longer confine us, where the cold emptiness of space is bridged, not by slow-moving rockets, but by a revolutionary breakthrough in physics. A warp drive. It sounds impossible, something straight out of Star Trek. Yet today, scientists are inching closer to unraveling the mysteries of faster-than-light travel. But how? How can humanity overcome what appears to be the ultimate cosmic speed limit? Could we ever build a spaceship that bends space-time itself, allowing us to traverse the galaxy as effortlessly as we once crossed oceans? The concept of the warp drive, or faster-than-light propulsion, has long been considered the realm of science fiction. But the roots of the idea stretch deep into real physics. At the heart of this limitation lies Albert Einstein's theory of relativity, which states that nothing with mass can exceed the speed of light. The faster an object moves, the more energy it requires, approaching infinity as it nears the speed of light. This fundamental rule has long kept interstellar travel beyond our reach until a radical idea emerged. What if instead of moving through space, space itself could move? Enter the Alcubierre drive, a theoretical concept first proposed by Mexican physicist Miguel Alcubierre in 1994. Alcubierre's idea sidestepped the speed limit by suggesting that space-time itself could be manipulated. Imagine a flat rubber sheet representing space-time. Place a toy spaceship on it. If you push the spaceship forward, it moves at a certain speed. But if you stretch the rubber behind it and compress it in front, the spaceship doesn't move at all. It's the fabric beneath it that shifts, carrying it forward faster than light could traditionally allow. In essence, this is what a warp drive would do. By contracting space ahead of a spacecraft and expanding it behind, a bubble of distorted space-time could carry a ship vast distances in a fraction of the time, all without violating relativity. This concept sparked immense excitement, but there was a major problem: energy. To generate this warp bubble, Alcubierre's model required an unfathomable amount of negative energy, something that, as far as we know, doesn't naturally exist in usable quantities. The amount needed was often described as more than the mass energy of the entire observable universe, making it seem utterly impractical. However, as physicists continued to explore the concept, new refinements were made. Researchers like Harold White of NASA's EagleWorks lab proposed modifications that drastically reduced the energy requirements. Instead of universe-shattering amounts, some calculations suggested it might be possible with energy levels within the realm of advanced technology. But how could we generate negative energy? This is where quantum mechanics enters the equation. In the strange and counterintuitive world of quantum physics, the vacuum of space isn't truly empty. Instead, it's teeming with fleeting particles popping in and out of existence, a sea of energy fluctuations. This phenomenon, known as vacuum energy or the Casimir effect, has led some researchers to speculate whether negative energy could be harnessed in small amounts. Could future technology exploit these quantum fluctuations to create a warp bubble? As we dig deeper, the challenges remain enormous, but so do the possibilities. In recent years, more studies have emerged exploring ways to refine warp drive models, pushing them closer to scientific feasibility. Researchers have proposed alternative shapes for the warp bubble, different ways to manipulate space-time, and potential exotic matter that could serve as the key ingredient for bending space itself. The idea is no longer purely theoretical. It's becoming a serious field of scientific inquiry. Even NASA has dipped its toes into this area, with studies on breakthrough propulsion physics attempting to explore how warp drive concepts could one day be realized. The question is no longer just whether the laws of physics allow it, but whether we can harness the necessary energy and materials to make it a reality. The implications of such a breakthrough would be staggering. Travel to distant exoplanets could take weeks instead of thousands of years. Human civilization could expand beyond the solar system, colonizing the stars in ways that seemed impossible just a few decades ago. But there's another perspective to consider. If warp drive is possible, could someone else have already figured it out? Some scientists have speculated that if advanced extraterrestrial civilizations exist, they might already possess the knowledge to manipulate space-time. UFO reports, particularly those involving unexplained accelerations and sudden disappearances, have led some to wonder if we're glimpsing the effects of unknown warp technology. While there's no concrete evidence to support this, It raises the tantalizing question of whether the universe might already be home to beings who have mastered interstellar travel. The road ahead is uncertain, and many hurdles remain. But one thing is clear: humanity has always pushed the boundaries of the impossible. What was once considered magic became science. What was once deemed unachievable, flight, space travel, quantum computing, is now part of our reality. If warp drive is within the laws of physics, history tells us that it is only a matter of time before we figure out how to make it work. While the Alcubierre drive remains one of the most well-known theoretical models for faster-than-light travel, it is not the only approach being considered. In fact, some scientists argue that manipulating space-time may be possible through other exotic means, possibly requiring less energy than originally thought. One alternative theory suggests that naturally occurring cosmic phenomena, such as wormholes, could serve as shortcuts through space-time, allowing us to bypass the speed limit altogether. Wormholes, or Einstein-Rosen bridges, are theoretical passages through space-time predicted by general relativity. Imagine the universe as a two-dimensional sheet of paper. Normally, traveling between 2 points on the paper would require moving across its surface. But if you fold the paper so that the 2 points touch, you could create a shortcut, instantly moving from one location to another. This is the basic idea behind a wormhole. However, traversable wormholes, ones stable enough for spacecraft to pass through, require exotic matter with negative energy to keep them open. The same negative energy problem that plagues warp drives also applies here. But if breakthroughs in quantum physics allow us to manipulate energy in new ways, wormholes could become a viable method of interstellar travel. There is even speculation that nature might have already provided us with microscopic wormholes. Some physicists believe that tiny quantum-scale wormholes may exist all around us, constantly forming and collapsing at the Planck scale, the smallest scale of the universe. If we could find a way to stabilize and enlarge one of these microscopic wormholes, we might have a natural shortcut across the galaxy. While this remains a distant dream, some theorists argue that future advances in quantum gravity could reveal whether wormholes can truly exist as practical transportation methods. Beyond wormholes, another mind-bending concept has emerged: the idea that the universe itself might hold the key to faster-than-light travel. Some researchers propose that the universe has hidden dimensions beyond the 3 we experience in everyday life. If these extra dimensions exist, as suggested by string theory, they could provide new pathways for travel, allowing us to bypass the constraints of normal spacetime. A civilization advanced enough to manipulate these dimensions might not need a warp drive at all. They could step outside of normal space and re-enter at a different location instantaneously. There's also the idea that space itself may not be as rigid as we think. Quantum mechanics has demonstrated that particles can become entangled, influencing each other instantaneously across vast distances. Some have speculated that if we can understand and control the underlying mechanisms of quantum entanglement, we might discover new ways to manipulate space and time. Could entanglement or other quantum effects play a role in faster-than-light travel? Right now, there are more questions than answers, but as physics continues to evolve, new possibilities are emerging. In 2021, physicist Eric Lentz proposed another intriguing idea. His model suggested that instead of relying on negative energy, a warp drive might be possible using classical physics and conventional energy sources. By structuring space-time in a specific way, he argued, one could create a warp bubble that allows a spacecraft to move faster than light without requiring exotic matter. While this theory is still highly speculative and requires further validation, it represents an exciting shift in how we think about the physics of space travel. Even with these theoretical breakthroughs, the engineering challenges of building a warp drive or other faster-than-light system are staggering. First, we would need an advanced understanding of space-time manipulation, which is still far beyond our current grasp. Then, we would require an energy source orders of magnitude greater than anything available today. Our most powerful energy sources, nuclear fusion and antimatter, are not nearly enough to sustain a warp bubble or wormhole. Some futurists believe that harnessing the energy of entire stars or even black holes might be necessary. This leads us to another fascinating idea. What if a sufficiently advanced civilization has already mastered this level of energy control? The Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev, measures a civilization's technological advancement based on its energy consumption. A Type 1 civilization uses all the energy available on its home planet. A Type 2 civilization harnesses the power of its entire star, while a Type 3 civilization controls the energy output of an entire galaxy. For a warp drive to function at a practical level, we may need to reach at least Type 2 status, where we can efficiently capture and manipulate stellar energy. Could this explain some of the strange phenomena observed in the universe? Some scientists have speculated that unidentified flying objects, UFOs, exhibiting seemingly impossible acceleration, sudden changes in direction, or vanishing from sight, may be using an unknown form of space-time manipulation. If an advanced extraterrestrial species exists, they may have already developed warp-like technology, allowing them to travel vast distances in ways we cannot yet comprehend. While this remains purely speculative, it raises an intriguing question. If nature allows for faster-than-light travel, and if the universe is as vast as we believe, is it possible that someone else has already cracked the code? Regardless of whether aliens have mastered warp technology, one thing is clear. Humanity is on a path toward unlocking the secrets of space-time. In the last century alone, we've gone from barely understanding relativity to quantum mechanics, black holes, and the possibility of manipulating the fundamental fabric of reality. If progress continues at this pace, it's not a matter of if, but when, we will uncover the key to interstellar travel. As we push the boundaries of physics, the dream of faster-than-light travel remains one of the most tantalizing frontiers of human ambition. While theoretical models such as the Alcubierre drive, wormholes, and extra-dimensional shortcuts offer glimpses of what might be possible, the road to making them a reality will require breakthroughs in both fundamental physics and engineering. However, history has shown us that the impossible often becomes possible with time, determination, and scientific progress. One of the biggest hurdles in achieving warp technology lies in our understanding of gravity and space-time itself. General relativity describes gravity as the curvature of space-time caused by massive objects, but it doesn't fully explain how quantum mechanics fits into the picture. The search for a theory of quantum gravity, a unified framework that combines general relativity with quantum mechanics, could provide the missing link needed to manipulate space-time at will. If such a theory is discovered, it may unlock entirely new ways of bending and warping the fabric of the universe, leading to revolutionary propulsion systems far beyond anything we can currently imagine. The study of black holes and their interactions with space-time is another promising area of research. Black holes possess immense gravitational forces, capable of warping time and space to extreme degrees. Some scientists speculate that by harnessing the power of rotating black holes, or exotic, cosmic structures, it might be possible to create stable warp fields or even artificial wormholes. While this concept is still purely theoretical, the idea of using natural cosmic phenomena as a means of propulsion could become a focus of future scientific inquiry. One of the most exciting aspects of warp technology is its potential impact on the future of humanity. With the ability to travel between stars in a matter of weeks or months, rather than millennia, we would no longer be confined to our solar system. The vast reaches of the galaxy would be open to exploration, colonization, and discovery. Exoplanets that were once unreachable could become new homes for humanity. Entire civilizations could be built among the stars, ensuring the survival and expansion of our species. Interstellar travel could also lead to the discovery of extraterrestrial life, whether microbial, intelligent, or something beyond our comprehension. The ability to reach distant worlds would allow us to directly investigate environments where life might thrive, answering one of the biggest questions in human history. Are we alone in the universe? If other civilizations exist, warp technology could be the bridge that finally brings us into contact with them. But with great power comes great responsibility. The implications of controlling space-time itself raise profound ethical and existential questions. If warp drives become feasible, who will have access to them? Will they be used for peaceful exploration, or could they become weapons of war? The ability to travel vast distances instantaneously would reshape geopolitics, economies, and even human culture. It would challenge our notions of distance, time, and society itself. Some futurists believe that artificial intelligence and machine learning will play a crucial role in developing warp technology. AI-driven simulations could help physicists model complex space-time interactions far beyond human capability. Advanced computing systems might one day uncover the precise conditions needed to create a stable warp field, bringing us closer to practical implementation. The fusion of AI and physics could accelerate humanity's progress toward interstellar travel faster than we ever imagined. Despite all these possibilities, the path forward remains uncertain. Many of the key technologies needed for warp travel, negative, energy manipulation, space-time engineering, and high-energy propulsion, are still in their infancy. Some skeptics argue that while warp travel is mathematically plausible, the practical challenges may be insurmountable. However, history has shown that technological breakthroughs often emerge from the most unexpected places. Less than a century ago, space travel was considered impossible. Now, humans have set foot on the moon, sent probes beyond our solar system, and are preparing for manned missions to Mars. As research continues, new discoveries in physics could tip the balance in favor of warp technology. Perhaps a new understanding of dark energy, the mysterious force accelerating the universe's expansion, could provide insights into how space-time can be manipulated. Maybe quantum field research will reveal new methods of generating negative energy. Or perhaps a completely unexpected breakthrough will revolutionize our understanding of reality itself. The dream of interstellar travel has captivated human imagination for centuries. It has inspired countless works of science fiction, driven scientific inquiry, and pushed the limits of what we believe is possible. The road ahead is long, and the challenges are immense. But if history has taught us anything, it's that humanity never stops reaching for the stars. Whether in a century or a millennium, the day may come when the impossible is no longer science fiction but a new reality, one where warp drives carry us across the cosmos, unlocking the secrets of the universe and securing our place among the stars. And so, we leave with a final question. When will humanity take its first true step into the warp drive revolution? Will it be in our lifetime, or will future generations be the ones to unravel the mysteries of space-time? One thing is certain. Our journey is just beginning. Please subscribe this channel for more interesting videos.